Blending is one of the most basic tasks in the professional kitchen. But there's more to blending food than many of us realize. Most chefs would agree that bigger is better when it comes to motors. And our blender, a Waring Xtreme, has as big a motor as you can get before the lights in the kitchen start to dim. The design of the pitcher and the blades is critical. The blades don't simply cut the food down to size, instead they act in concert with the shape of the pitcher to compress, shear, and even cavitate the blending food. And flow is also important. A well-engineered pitcher, like the one on our Waring blender, keeps the food flowing past the blades without the need to plunge a spatula into the mix. As you can clearly see here, liquid at the top of the pitcher is being pulled down by the blades before being cut and flung out to the sides of the pitcher. This is efficient blending. A final factor is the durability of the blades. A solid professional blender forges its blades from exotic steel alloys that are extremely hard, keeping the edges sharp even after grinding the toughest foods down to size. Really hard, durable foods strain the motor and work to dull the blades. An extreme example is grinding wood chips into small fragments for our kitchen smoker. A lesser blender would overheat before getting the job done and the blades would quickly dull. But not everything in the kitchen needs such brute force. Sometimes it's better to use a bit of finesse and turn down the speed of the blade to do the best job, like for our olive puree.
A clever and fast way to remove pits from olives for making tapenades or purees is by blending them on the lowest setting. Blend the olives with no liquid for about 30 seconds, or until the pits are completely clean. Working on the lowest setting allows you to chop through the meat of the olive, but not crack the pit into shards. Once you have blended the olives for about 20 to 30 seconds, you can empty them out into a container and separate out the undamaged pits. At this point, you are ready to make your tapenade, or you can return the olive meat to the blender and continue to blend into a puree. With the aid of Waring's high-powered motor, you can blend durable foods like raw carrots into a soup with nothing more than a little water and time. To do this, add clean and trimmed product to the blender and add just enough water to blend. Once the food begins to cook from heat created by friction, it is only a matter of minutes until it becomes a velvety smooth puree. But blenders can only puree something so fine, so blending for long periods of time will not yield an increasingly fine puree. However, the longer you blend the puree, the more the flavor will develop and change as it becomes hotter and further reduced. This is by far the easiest way we know how to make a smooth vegetable puree. In order to blend something like peanuts, which seem very dry but contain a large amount of oil, it is important not to blend too quickly. You will also need to consider the volume you are blending. Too little and the peanuts are flung to the sides and never make contact with the blade. Too much and the peanuts will stop flowing and the blades will free spin, at which point you will then need to scrape down the sides over and over, and this can become a huge waste of time. To blend the peanuts into a butter with minimal effort, start with about 600 grams of nuts on the lowest setting until they become fine pieces and begin to flow. At this point, you can begin to slowly turn up the speed. As a blender becomes warmer, the fat in the nuts begins to thin, and as this happens, the puree will begin to flow smoother and smoother. You can decide when the nut butter is finished based on how coarse or how fine you want your nut butter. These are just a few of the many amazing things you can do with the Waring Xtreme blender. With its powerful motor, excellent blade design, and lasting durability, the Waring Xtreme is a great addition to any commercial kitchen.
Most of us use a blender without giving thought to how they do the job of cutting food down to size. Like most people, you might assume that the fast-spinning blades cut the food directly, but blenders have a secret. Cutting is only important for the first stage of blending. Once the bits of food become small and begin to flow, unseen forces come into play. Truly powerful blenders, like this Waring Xtreme, generate hydrodynamic forces that impart the energy needed to turn even the toughest foods silky smooth. As the blade sweeps through the fluid at the bottom of a blender, intense shearing forces literally rip particles of food apart. But it's the seemingly benign implosion of bubbles that is truly violent. These forces are normally all but invisible, but using our high-speed camera we can slow time and let you see how blending really works. Initially, the impact of the blades cuts the food directly. This is important because for a blender to work, pieces of food must be small enough to start to flow under the stirring action of the blades. Does it flow? Is the answer to the question, will it blend? commercial-grade blender, like our Waring, has enough power that the impact of its blades can shatter some tough stuff, such as handfuls of whole spices like cinnamon stick, cloves, star anise, and peppercorns into a fine powder. Even a fistful of golf balls can be quickly cut into bits, but at some point, the pieces don't become any smaller for two reasons. As they shrink in size, the chance that the blades will hit them decreases. They've simply become too small a target. The second reason is more fundamental. As the pieces become smaller, it takes exponentially more kinetic energy to break them smaller still. At some point, the blades simply cannot hit the food hard enough. In the next video, we'll explore the hidden forces that do the real work of blending food smooth. As the blades of our Waring blender spin through liquefied food, forces other than cutting are responsible for most of the work of blending. A powerful shearing force drives circulation by sucking liquid down from the top of the pitcher and then violently flinging it out to the sides. Here, as oil tries to slip past the fast-moving blades, the turbulence literally rips it into minuscule droplets that are dispersed into the surrounding liquid to create a rich, smooth emulsion. A remarkable amount of engineering effort goes into the design of the blades and pitcher to maximize this force. Those of you watching this video closely might notice another oddity. As the blades begin to spin, an uncountable number of bubbles stream from the tips and trailing edges of the blades. This is the telltale sign of cavitation. These bubbles are tiny holes ripped into the surrounding fluid. Cavitation might seem benign, but when these bubbles collapse, a powerful shockwave reverberates through the liquid that breaks apart surrounding bits of food. Indeed, cavitation is powerful enough to shatter glass. Quickly smacking the top of this glass bottle, for example, creates a brief moment where a few cavitation bubbles appear within the water. When these bubbles pop, the resulting shockwave propagates through the water to the surrounding glass bottle, shattering it instantly. Although it's too fleeting for the eye to see, this same phenomenon is occurring every time you flip the switch on your Waring blender. The impact of these shockwaves is immense and breaks surrounding particles of food into incredibly small pieces. This is the unseen force that a blender uses to cut foods down to size.